Thanks, everyone. It is my great privilege to be invited to give a seminar here at Northern Arizona University. Especially, I know a few colleagues here, and plus it's nice to get out of the fog and rain from Humboldt. I called my wife. It confirmed that there's a little drizzling going on with a very thick layer of fog. So it's nice to get out of there and enjoy. This morning I had a trip to that Forest Service experimental forest on the full sunlight. That was cool. So I don't think I need to take a vitamin D medicine tonight. So anyway, it's really good to be here. When Yunsu contact me, see if I can share some of ideas of what I've been doing, and Humboldt share with you all about a biomass operation. So I said, yeah, that'll be wonderful. I love to visit the Flagstaff, and I never been to it. Yeah, this is the first time I came to Flagstaff. So I have a wonderful impression so far. It's been great. So anyway. So today, I would like to share with you some of the study I have been doing in Humboldt, and plus at the end, I'd like to also introduce the study we did 10 years ago of mechanical fuel reduction thinning here in Arizona. That would be my conclusion of my research. I also give you a little bit of an idea about the major project I am taking the lead. I also give a little bit heads up on that as well, what it's all about. So today's presentation, I'm going to talk about some of the biomass operations in relation to fuel reduction thinning as a logging slash operation. Especially emphasis in the utilization of the forest residue. When I say forest residue, I am talking about SERP, merchantable size of small diameter whole tree, typically coming out of the forest restoration or fuel reduction thinning operation, and plus some of the logging slash you're looking at like that. That's what I consider now as a forest residue. Now, these materials are typically difficult to handle because they are not uniform in size, and typically has a very low bulk density. So it is difficult to handle and haul as the material as it is to the market. So this material usually goes through some kind of the pre-processing in the wood, chipping to produce a relatively uniform material. It's because chipping you use knives, and this grinding uses a hammer. So with the hammer you have a little bit lack of control. It's what kind of size of the material you produce. So you got the grinding, chipping. It's not a common practice, but people have been testing about bundling. The idea is to compact densify the material to increase the density so that more efficiently can handle. That's the idea. So any one of these kind of methodologies has been incorporated any kind of biomass operation. So now, if we look at the biomass operation, this biomass operation is at the landing. So meaning that this grinding and chipping taking place at each landing, each harvesting site. That's been one of the most common practices being done these days. Now, this is you see that the logging slash left from Shelterwood, the thinning operation in northern Idaho, and you see the logging slash piled right by the road. In this case, a team of a loader and the grinder coming into the site and directly grinded the material and directly load onto the truck. And then the truck hauled the material to the market. So this kind of the grinding at the landing is a very common method being used even today. And then another common operation like that would be along with the fuel reduction thinning. When you do fuel reduction thinning, it generates lots of the submerged small diameter whole trees, and those material can be directly chipped or ground at the landing and haul the material out to the out to the market. So this kind of material methodology is very common, but there are some issues. So even though those methodology is a very common and very efficient in a lot of ways, but we have some issues with that approach. First approach is when you do look at using that system, moving harvesting site to harvesting site, you're looking at some, you're going to face some sort of the limitation of the access to certain area. Now, if you look at the highway chip van, this highway chip van initially is a design for hauling on highway, not on the forest road. If you look at the ground clearance, it's very low, less than 1 foot. Also, you're looking at this body, that's about 40-foot long container. It makes a very wide turn. So, but a lot of road, the forest road is mostly designed for hauling saw log, not for highway chip van. So that means that even if you have a lot of volume out there, if we try to put this one in along with the loader, you may simply don't have access. Okay, so in that case, even if there's a market, you're trying to get it, but you don't have access. Number two, this material, biomass material, forest residue material, usually characterized as a scattered. It's scattered is over large landscape, meaning that this team of the grinder and loader has to move one unit to next unit to the far next unit. So it's this kind of the frequent move. We basically it's up of the time at that time can actually utilize for the production of the biomass. So you're looking at a lot of operational delay. It's just spending a lot of time just to move around. However, just to give you a quick idea about equipment, this grinder, the horizontal grinder, that's a 1,000 horsepower. That's a $650,000 machine. This loader here, this is a $450,000 machine. You're looking at over $1 million investment. You cannot afford to move too frequently between the units, especially when you deal with the material has almost no market value or very low market value. It is very difficult to do that. So about 9 years ago, I was working with several people that we came up with the idea about centralized processing. It is an alternative to trying to address the issue, right? The two issues, accessibility issue and the material being so scattered, that issue, it can be effectively addressed with a centralized processing approach. So that's been tested 9 years ago, and now we actually use this approach used quite often. So let me introduce that idea about what it's talking about. Idea is that the using this small truck, logging truck or hook lift, roll on off container truck or dump truck. So you got small body, okay? You have small body with high ground clearance. And you can use those small truck to pre-haul a whole tree, logging slash, or even bundle into centralized chipping or grinding site where the material will be either chipped or ground. And then the material will be eventually hauled to the energy plant. And this location, centralized grinding location, will typically will have access, good access with the highway chip van. That's the idea. So with the idea, what we are looking at, okay, with that approach, we possibly improve the access, okay, to the scattered, the remote, the residues. That's the idea. Secondly, you're looking at can we effectively minimize the machine time in grinding operation that the chipping, the chipper and or grinder along with the loader is the most expensive component of the operation typically. So can we keep them busy all the time at the expense of, we willing to allow some delay with some other small trucks. But as far as the grinder and loader, they have to work like, almost 100%. That's the whole point. So see if we can do that. Another thing from doing that, we also incorporate some ideas about decoupling. some of the activities actually can be decoupled so that the activity does not impact on the next activity. So that kind of ideas also we incorporated into this centralized pre-processing concept. So next for trial, we applied this concept. Start with one I did in 2007 in Northern California with Six River National Forest. Using that the shaded field break treatment. This shaded field break treatment basically using the chainsaw, breaking up the continuity of the field by cutting the brush and small diameter trees. But still, you're trying to maintain the high level of crown closure up to around 60% so that sunlight doesn't hit the ground. It's discouraging the brush coming back up so that your effectiveness of the treatment it can last longer. So that's what that kind of a treatment they apply. Now, from that treatment, using the slash, using the chainsaw, they hand cutting of the brush and small diameter tree and hand pile like this, like that, and then when the weather allow, they burn it. So that's how they're trying to address the fire danger issue. Okay, well, do you have some issues there? Number one, when you're trying to do that, your burning window, as you know, is very narrow. Okay, it's in Northern California interior. It's a very hot, dry summer. So if you look at the burning window, you're looking about a month year-round. That's the only window you have for burning this kind of stuff. Number two, when you're trying to burn, it also kills the trees. And also another thing, important issue to the practitioners is a high cost. It can be low as $150 per acre to up to $1,000 per acre. There's a high cost involved. So I joined the Humboldt State University in 2007, and I heard this kind of story. So I talked to the people, hey, you know what? Give me $500 per acre. I will mechanically remove it out of there without burning. And they just grab me like this, and okay, Han, are you sure? Yes, we can do it. So he said, Han, we have a very steep terrain here, very curvy road. Chip van cannot get in there. Okay, how are you going to do that? Well, let me do it. So I explained briefly about using the roll-off container we studied in Montana. And I showed them, explained them, and they said, that's a good idea. Let's try that. So they came up with the funding, and then we tried using this small loader, skid steer, small loader, traveling. It's a rubber track skidder. It doesn't cause any soil impact. It's going into the unit and grab stuff, put it under that bin, 40 cubic yard bin in there. And then once you get fully loaded, and then truck coming in and pick it up and roll on to the truck, and then taking it out to about 3.5 miles away. There was some old big opening, the sawmill site, sawmill yard that's been closed. So dump it there, and they punch a whole bunch of them, and then later the grinder came in and ground up and then supply into local power energy plant. So we did that. From there, to make just a story short here, the cost of the green ton was about $23 per green ton. Now that translated into that area we study on. That's you're looking at somewhere around 8 to 10 ton per acre. That translated, the cost can be that mechanical removal of that biomass can be done within less than $300 per acre budget. And the supervisor of the Six River National Forest was so excited. So because you do not have to wait for the weather condition to burn that thing, they can actually remove it and then utilize it. So they are really excited about this kind of idea, and the supervisor asked the district managers to consider this option if that is possible, appropriate. So we thought that was a good application we had there. next to three slide, three trial, you'll see the mainly using that small truck in the centralized processing with a logging slash in timberland. So we 2008 we put that the roll-off container, the hook lift being left on the ground, and then loaded with a regular loader in the typically used for timber operation, and then put it on the hook lift truck coming in and pick it up and take it out to the old rock pit. So they have accumulation of the huge amount of the biomass there, and that particular rock pit area had access from with the highway chip van year round. And then once the material was ground and hauled out to the energy plant. So idea in this case was using that the hook lift truck to pile all that residue material into one big opening area. And from there, the final cost was about the $32 per bone dry ton. To give you an idea about a little bit of the market situation in Humboldt County, you're looking at somewhere around the local power plant, they pay somewhere around between $40 to $50 per bone dry ton. Okay, so with that money, there's a little bit of room for hauling, okay, without going negative. Now, one thing I have to tell you though, in this case, putting the stuff on the container with this one, with the long stick material sticking out, it's not that actually easy. So you'll see that later, this cost can be significantly reduced. So you can see the loading cost. So that's the one we learned. Next, second one, we looked at the same year. We also had the John Deere, a bundler came into Humboldt, had some demonstration and the study, see how it works with the logging slash in Northern California. And so a bundler came in and the bundled and the hook lift truck used to, in this case, the container did not load it down onto the ground. They just load the bundles onto the container and then put the pile into that open big gravel pit yard. And then another thing is what we did. This is a whole tree hardwood. It's a whole tree hardwood bundling, and then make it bundles. And then we also use the hay rack, the logging truck, just to haul them out to the rock pit site. And then there was material was ground and then delivered to the energy plant. Now, give you a little bit about this bundler. It works. It was this machine is about $450,000 machine. It spent much time of the grappling here. It's almost half time. It's just trying to make arrangements. So because the slashes are tangled each other, so you need to sort it out so that you can nicely fit it into the bundling bed. So it took so much time, most of the time for that, and the producing like that, it ends up what we saw about you're looking at 30 bundles per productive machine hour. So that's kind of a productivity you're looking at. So with the the production is not too bad, but the product price of the machine, it seems to be a little bit too high for handling this one. Either you have to have a very high level of productivity of the operation when your machine is expensive used, or you use a low productivity but very low cost option. That is the only way you can oftentimes financially, economically feasible to make it work in biomass operation. So now what we looked at here, now how are the loading? Because it's all bundled, so loading cost was very low. And hauling, because it's already bundled in that pack, densified, so your hauling cost goes down too. But your bundling cost is way too high. It ends up a lot more expensive operation for that. Next to the trial, we looked at the modified dump truck. So this is a third trial handling, logging slash recovery operation. So now you're looking at, you see that this dump truck is typically used for civil engineering, building road, building bridge, that kind of stuff. Now, it carried that very heavy rocks and there was sand, dirt, that kind of stuff. It have capacity about handling 30 tons. Now, to give you an idea about weight of the biomass, you know, the big highway chip van, that's a 120 cubic yard container, it carrying around 25 tons. Okay, so that gives you an idea when you're looking at about 30 tons. That's what that means. However, it carries only 21 cubic yard. Okay, now there was a very, very innovative contractor in Northern California. His name is Steve Morris. I've been learning tremendously from him. So all of the things here, I don't get any single credit. All credit should be given to that contractor. All what I did, I just monitored. Okay, so that's all his works. I want to tell you that. So what he did, he bought used machine at a very low price, and then he modified, put the more sidewall, and then you put the even tail, open tail like this, and I just stood up here to show how much increased the capacity as a volume, because this truck is not limited by the weight when you're hauling biomass, isn't it? So by doing that, not only that, the reason I have this photo here, you see a lot of material sticking out. When you haul the material going beyond the tail, it is allowed on their property. It's not allowed on the highway, but it is allowed on the property, private property, right? So by doing that, even though that's I say 58 cubic yard based on my calculation, it actually over 60 yard it carry each trip. Okay, so for container, roll-off container, hook lift container, you're looking at 40 cubic yard. You see the difference. Not only that, but also this one, in material, because the end side is open, you don't have to break it out. You just put it on it. That's it. You don't have to break and try to squeeze into the container. You don't have to do that. Now, as far as the grinder, because of the horizontal bed grinder, the length doesn't matter. In fact, that's good. You just put it on, it just automatically fit it in. So length doesn't make any negative impact on the grinding process. So this is perfect. So I have to show. I would like to say about this was a huge, very wonderful renovation of what he did. Now with that, the loader, even that the slash is scattered throughout the harvester unit, the loader going in and compile it and put it on the truck, or this loader grab the slash at the landing, put it on the truck, and haul it out. You're looking at about 1.5 miles. You don't want to go too far, 2 miles, because it becomes very expensive, even that dump truck. So usually less than 1.5 miles pre-haul to the grinding site. In this grinding site was a small grinding site. Even though central grinding site, it is a small grinding site, optimally located, so that you can effectively minimize the pre-hauling distance for about 4 or 5 harvesting units around it. Okay, so this one landing serves for grinding all the material in the left in over 4 or 5 harvesting units. For your information, in California, the clear-cut unit cannot be bigger than 20 acre for ground-based system. For cable, you can go up to 30 acre unit. That's a maximum clear cut you can have. So anyway, so that one central location serves for another 4 or 5 units, and grinding it, and then now I want to show you another one. One thing, this contractor is so innovative. He actually decoupled of the this operation from this grinding operation right here, grinding and pre-hauling, all that. The reason he did that, let me show you what he did. So here is the dump truck picking up the slash from this unit. This is the brown area. That's a recent clear cut or 1-year-old clear cut. And this slash is pretty hard to the here central grinding. You have a 2 all-wheel drive tractor. Now, even that some area, you're trying to put this van over here. This area even have a problem with the highway chip van. However, he modified a truck to put that power driven applying into 4-wheel, a 6-wheel. So this is a 6-wheel tractor. So you have a better, greater ability of climbing on very steep terrain. Okay, and he got 2 trucks like that, and then basically he used 2 trucks. Rotating the container here, taking the container with the fully loaded with the chips, bring it down here. We call trailer landing, and you have a trailer landing about 20 of them here until until then this highway chip and truck doesn't come in. I mean, it's a truck coming in only. You have about 20 or more of the trailer is fully loaded with chips or hog fuel. So this operation is decoupled from this operation. So this operation does not impact anything with this guy. So this truck is going to be working all the time, and this one is busy all the time. Again, they are willing to allow a little bit of the delay. This all-wheel chip van delay a little bit, so that as soon as this one is fully loaded, this will move out and they're coming in, so that this grinder can continue with the grinding. So that kind of setup has been, that's kind of a logistics he came up with. That was so brilliant. So we found the very interesting things what he did. So what we found, it takes about 30 minutes for that 1,060 horsepower grinder the make of one full load of the chip container. So you're looking at somewhere around 38 bone dry ton per hour. That's the dependent moisture content. That's the kind of things you're looking at. So from here, upstream and downstream, it's trying to make a system balance. If we keep that make a balance, so everybody is working all the time, is the really key to the success, or key to minimize overall operational cost. So that's how much they're working on it. And then, as I told you, this secondary hauling from that central landing to market is decoupled. And by doing that, all these entire operations stay very, very efficient. So with that idea, you see the loading cost is only $3. And the hauling cost was instead of $10, now you're looking at almost $7. So ends up, you're looking at $24 per bone dry ton. So he's doing great. So let me tell you this. Let me share with you this idea. So this contractor, he's using this dump truck only in his operation. Initially, he started with a hook lift container, and now he's only using the dump truck by his biomass operation. Just for also your information, he getting a revenue from 2 places. One, selling that when deliver the material to the power plant, he get the revenue from there. Okay, between somewhere around $40 to $50 per bone dry ton. He also getting payment from the landowner, because landowner having a huge problem with handling logging slash. And for the particular forest products company, they spend at least $300 to $800 per acre for slash management, including weed control. After prescribed burning, a lot of weeds pops up. So spraying the chemical, all that together, you're looking at $300 to $800 per acre. You're looking at. With this approach, they don't do that. They don't have to spray chemicals. Slash problem is resolved. They do not have to delay. They are tree planting because of slash. Slash is being gone. So it really facilitates their tree plantation right after their timber operations are completed. So there's no delay. That is a very important thing to the company in that particular area. They're looking at about 50-year age of rotation. Within 50 years, they can grow the timber about 25-inch DVH. They're growing very fast. They do not want any year of the delay. They lose a lot of money by doing that. So it's important things for them. So they are willing to pay the contractor, biomass contractor, to get rid of the slash out of there. However, that they always negotiate. It's very close to the market. They don't pay. If this is a really far away market, then pay a lot of money. So they have some discussion and negotiation taking place all the time. So what we learned from this trial that the centralized grinding small truck really works well with improving road access and minimize the delay. And also the system, creating the best system balance is really important. Small mistake in unbalance, it can cost you a lot, big time. I say big time. You almost economically feasible or unfeasible. You can move either way depending on whether your system is well balanced or not. We found it in many cases. And the low cost option is really good, especially that machine has high productivity. That's wonderful. Other benefits we highly recognized. And to be honest with you, I like to tell you because it's a forestry seminar. I am a forester. I'm not too excited about just producing electricity using biomass. That's a good bonus. I love that. More important thing to me as a forester, the removing the slash out of there so that the forest management activity keep moving on. That is more important to me. If we look at the biomass energy portfolio, I mean the entire country, United States, it's less than 2.5%. Even if the biomass energy double up, it's still looking at 5%. You see what I'm saying? So impacts on the significance on the energy independence using the biomass energy is really kind of a dream. It's a help, but it's not. You're not going to resolve the problem. From me as a forester perspective, these benefits, other benefits, is the more important to me. From there, if I can produce it, if I can use it for good purpose, yes, I'm very happy about it, which is energy. So, that's kind of that's why I'm so excited about the biomass operations project. It's more about forest management than energy production to me personally. Now, well, we have so far we've been talking about the inward biomass operations. Okay, so are we done? Are we solved? So it's going to happen everywhere? No. Why is that? Why is it not happening everywhere? So this is a seminar. What do you think? Why is it not happening everywhere? So now it sounds like we know we figured it out already, how to do it. So why still biomass operation is not taking place everywhere? Why is that?
I would say because, like you said, with the careful balance between feasible and unfeasible, I mean, if expenses go up, fuel costs go up, then you're unfeasible again.
Yep. So the operations is still quite cost sensitive. So you have to really stay efficient, otherwise, do that. But that's kind of what we've been talking about. There are some other big reasons. Another major barrier that cause biomass operations still not financially feasible in many cases in the country. What's that? Anyone? Market is a big one, yes. As a market determines what? Market is a big one. Yes, that's absolutely. So the market determines. How? Oh, it is a very. When I went to the eastern Oregon with the Roseburg Forest Products and the local area at power plant, they go down to $24 per bone dry ton. That's not nice. And the highest I found is the Humboldt County. That's a $50 per bone dry ton. And the central northern Idaho, Lewiston area, they have the pulp and paper mill, has a power plant. They also pay close to $50 per bone dry ton. Okay, so going back to the market issue. Now, what's going to happen if if there's a market? You still have to all what we've been talking about so far, from ground to the truck, isn't it? We have not talked about from landing to market power plant. We have not talked about it. So, well, in fact, the lot of financial feasibility of the biomass operations is less likely the operations efficiency, more likely transportation cost. Transportation cost. That is probably the bigger. That would be bigger challenge for us to handle. So let me show you that example. What do we mean by that? How important it is about understanding about transportation. By using the one example we did here in Arizona 10 years ago with my grad student. And so one of the study we did with the local contractor here with the one fuel reduction thinning or restoration setup operation, which kept the biomass the tree to be cut up to now about only 5-inch DBH. Anything bigger than that, stay. So I was contacted by some Forest Service staff asking me that, Han, we have a very good idea for any stewardship contract. We can come up with a very fair price, what we may put that in the contract language, okay? We feel we have a pretty good idea. However, I have no clue if we did an operation is deal with only trees less than 5-inch DBH. I have no idea what would be a fair price put it in the contract. So I'd like you to do it, and we try to have some ideas about what it number look like. Okay, so that's why I was contacted, and then we did that 10 years ago. So now if we look at this stand, this is you see that this is a pre and post. Unit number 1, DBH was a 5-inch DBH. That's a mean. To after thinning, you're looking at 8-inch. But look at this one, unit number 3. Its mean DBH was 1.762 after thinning, 5.7. Now, how about stems per acre? It was from what you see here is the numbers you left after thinning. I mean the removed, but from 670 to 264 per acre they left. So and here about over 1,000. So you got so many stems per acre, high density stand, and but this operation is really mainly targeting the trees less than 5-inch DBH. What the look like of the picture, that was before, this is after. As you see, this was it's still same thing when I went to the Forest Service experimental forest this morning. That there are a lot of area I see is still like this, and I saw also some area thinned like this. So it's still the case. But anyway, that's what the stand condition look like. So the contractor used a through-wheel fallow buncher, and then using the grapple skidder, robo-tired grapple skidder, and then that one pulled out to the landing, and then there was a chip, and then hauled to the landing, to the market. Now, this is the material, this is the methodology we talked about earlier biomass processing at the landing, right? That's what it was. Apparently, there was a good access with the highway chip van. That was the case. So we looked at the Fallon cost, skidding cost, loading cost, grinding cost, and then you got the hauling cost, hauling distance. We had a 4 units, a study unit, 4 study units. It has a distance about 30 to 36 miles, one-way distance. Okay, and the cost from stump to the power plant was $55 per bone dry ton, with no allowance of profit, risk, overhead excluded. So that's the price we got. And now, so anyway, that's kind of a give you an idea about what the cost we got. Now I want to cross my point about problem with the transportation and the challenge, high cost of the transportation. So in this study, what we did, you see the 4 units, like 1 unit, 1, 2, 3, 4, and you look at the average speed at the bottom here. And then in very bottom, very right-hand side column, you're looking at total cost. So now, if you look at the compare between unit 1 and unit 4, a distance, unit 4 here is higher, more than unit 1. However, total cost at this one is lower than this guy. What's going on there? Well, what we found there is that this unit 1 has a spur road at 1.5 mile at the speed of 2.67 miles per hour. And unit 4 has no dirt road. It has only highway mileage of 36 miles at the 44 miles per hour speed. Okay, how does that translate? That is the main reason why the cost is a difference like that. Well, so if we convert, we actually had some initial calculation. Okay, 1 mile of the spur road hauling cost is about almost $7 per bone dry ton, compared to 1 mile of highway is 18 cents per bone dry ton. Because each van carry the same amount of the wood, isn't it? Yeah, about the same amount of wood. So depending on how fast you can make a round trip, that determines cost. That again, take one more step, translate it, 1 mile of spur road equivalent to 10 miles of unpaved road, or almost 39 miles of highway. So here's my comments for you. I have been asked by the public when I make an oral presentation in a public setting. People often ask me, Han, we are thinking to put our power plant right here. Can you tell me how far we can go out, what the mileage, one-way range of the radius, we can go out, get the supply into this power plant? How far can we go? Okay, and so we have here, we got 30 megawatts, big power plant right here. So how far can we go without that transportation becoming crazy? How far can we go? My answer is, that's not how you do it. The answer is, how long it takes to make a round trip. You go by time, not by distance. Because you got only 10 miles from here to there. That is all first road, compared to you got 50 mile highway distance only. This is much faster than that thing. You can make 3 trips here. You can make, if you're lucky, make 2 trips here. But time is money. So with that idea, when you look at the transportation cost, a lot of the fuel reduction filling treatment, biomass operations require this cheap van going through a long distance of the first road. That has a fundamental problem right there. Because first road is not designed for high speed. It's designed for maximum probably about 35. If you feel you can drive 40, that's a highway on the first road. more likely 20, 25 in average in forest road. So if you have a long, if the biomass has to come out to the highway 10 mile, 15 mile, it becomes no matter how efficient you are in grinding operation, going out to the highway, to the market, simply kill the project. Not financially feasible. So that's been a major issue. So that's been, well, actually, it's not necessarily new to us. We already knew about it. But I'd like to just emphasize that so that I can still go on with my next story. So now, this study we did here in Arizona, it clearly shows that story. Now, you're hauling the stump the truck is a $55 per bone dry ton, but hauling about 30, 36 miles one way, you're looking at that cost, hauling cost represents almost half of total cost. You see that? It's half of total cost. So transportation cost is still major issue we're dealing with. So are we done? So we just give up? Well, no, we're not going to give up. So what we've been thinking lately, last about 4 or 5 years, okay? People thinking to integrate some mobile biomass conversion technology. So instead of taking the wood chips out to the market, okay, power plant, why don't we bring the power plant into the wood? By doing that, we can do a couple good benefits right there. If we convert to this kind of the wood chips and some sort of, this is what we call biocoal, the biochar, and then densified into high density biocoal like that, that price can be, the value of this one can be 10 times higher than this guy. Okay? So your value increased. You added the value there. Number two, because of material, this one actually, material, some of the perfection machine, that kind of stuff, it becomes hydrophobic, zero moisture content, okay, zero moisture content, and it becomes hydrophobic, easy to store, okay, with no storage, but it's more importantly, it's a very high density, especially energy content wise, very high density. So the value is high, your transportation efficiency is going up, way up. So we are thinking to incorporate this kind of operation into your current biomass operation. By doing that, you can improve the value and improve the transportation efficiency. We may be able to address the fundamental problem, challenge with high transportation cost. So that is the approach we are taking. So what we are thinking, this is kind of a conceptual model we are currently working on. So we have a mobile technology right here, and then we have a central satellite chipping area, a grinding area. Will all supply into this portion, and once you process this one from here, you can go to Phoenix. No problem. That's the concept we are working on currently. With that idea, this idea has been converted into a proposal 2 years ago, and we submitted that proposal to Department of Energy, has been selected, so we got about $5.8 million for that over next to 3. We started last year, and we have tried to developing incorporate 3 biomass conversion technologies. They are gas fire, torrefaction, and briquettes. They're making it briquettes in the wood. So with that idea, we have 3 groups in our team. The feedstock developed, that's taking the lead, and we have the conversion technology group, and we have economic and the financial analysis, the economic analysis and the environmental impact analysis, including, is it Daniel? Including the biochar, okay, including the biochar application. So, and with I think that ends my story. Thank you. Sorry, I did not leave a lot of time for questions, but I'm happy to take any questions. Okay, I think you first. Yep, good question. One of my collaborator, his name is Ivan Easton, is the forestry marketing faculty out of the University of Washington. He's looking at a domestic and international market value of the biochar. We do not have the markets formed yet for biochar, not available. So that's his task in our team. But he's thinking that it can be small as probably 150, can be high as $300 per ton. That's his initial idea, but he will find more about it. And the question back?
Yeah, the farm management officer on the Tonto National Forest has told us that the biomass removal has been so thorough on the Tonto that they don't really have enough fine fuels, plus the disturbance from the equipment causes there to be less grass growing, and so it's hard for them to get back in there and do follow-up burns or even initial burns. And so my question is, how thorough does the removal of the biomass have to be for it to be economically viable? Do you have some wiggle room in there to leave some material to help with the fire management?
Okay, the two things I can say. One thing, we do not start with how much volume is out there, so it's economic feasible, so we're gonna get it. That's not how we go by. We usually start with, okay, there is a slash material that you have to get rid of, you want to get rid of, and whether there is economically feasible or not, you may still have to do it. Then that's what it's gonna be, there's a subsidy or you figure it out. That's the one answer I can tell you. Next one I can tell you, one of the study I'm conducting, we did already 2 of them and the 2 papers coming out. That is when you look at the 10 ton out there, are we really can remove 10 ton out there? No, not even half. What I'm saying is when you're trying to, there is a 10 ton of the biomass on the ground. In fact, Humboldt the company there, you're looking at somewhere around 60 to 80 green tons per acre. Now, out of that, if you're lucky, you can get the 40 ton per acre out of it. What it is, there are a lot of loss of the biomass during handling. You cannot vacuum the biomass out of there. You grab it as much as you can, put it in the truck, but you still leave a lot of limbs and branches on the ground. So estimation of the biomass, what's out there, it's not really how much you can get, collect and supply into local power plant. That's wrong. So a lot of older papers as to determining what kind of a horsepower or the megawatt power plant you're going to build based on inventory analysis surrounding area, that is wrong. That is very dangerous. Because the material out there, even though you can get the 100 ton every year, you can constantly sustainably supply, that is just based on inventory analysis. If we incorporate operations perspective, how much we call actual recovery, it's less than 45%. Many cases, low as a 15, high as a 70. That's a big barrier in there, based on our study. So people need to be careful about when you're talking about inventory, and then they develop the power plant based on that inventory analysis. It's not a wise thing to do. You have to go a little one step further there.
So most of these places are forestry companies that are logging for lumber, and then they want the slash taken care of so they can plant more trees. Is that it? Well, what happens to the soil over time when they take away all the biomass that would normally decay and enrich the soil again?
That's exactly what I just said. What I'm saying is, if trying to remove, you not vacuum that thing.
No.
You leave still about between 40 to 50% left behind.
To let it rot and
No, there's not a letter. Even if you're trying to clean that up, you still, that's how much you leave behind.
yeah, you need to leave some.
That's what I've been hearing, yes. A lot of people talking about it, yes. The people, when we talk about biomass operations, that's the one of the common question I'm getting from audience. Hey, hon, that's not sustainable. You're wiping out, you basically deteriorating our soil productivity over time. That's not allowed. That's not acceptable. So so that's one of the things what we are studying on our side here. One of the soil scientists looking at long-term site productivity, and she has done already actually quite more than 20 years actually. But she's expanding that idea with the biochar application even more. So my answer is, first of all, I'm not a soil scientist, so I cannot tell you a definite answer. But as the story I'm hearing from soil scientists and the study I did personally, we are leaving, let's say, somewhere around 40 to 50% behind it. And the soil scientists said, unless the certain species like gram fir, which require high demand of the nutrient, they require a huge amount of the nutrient. So you better leave a lot on the ground. For ponderosa pine, you don't have to worry about it. You just grab as much you can if you want to. Our primary objective is fire hazard reduction. Okay, so, and the ponderosa pine is really resistant and they're growing well on the poor site condition. So go for it. So that kind of a message I've been learning from other people. Yeah. Yep. I think Steve has some questions for me. The most difficult question for me, right, Steve? By the way, Steve and I worked together at UNBC in Northern British Columbia a long time ago together.
So I noticed that you've done a lot of your work on private lands.
Correct.
But you have done some work on Forest Service lands.
Correct.
Do you see any operational issues? Because we're all on Forest Service land, there's all government lands. Do you see any additional challenges doing this kind of work?
This is a wonderful question. That's why I love Steve. My answer is yes. Definitely different. My approach will be totally different. If I were assigned with that task, I am going to probably go with biomass at the landing, a biomass grinding at the landing approach, which I propose first. Because for national forest, your harvesting units they are so apart each other. One here, next one is 10 miles away. You cannot make it group it together and you have one central grinding location. That's not typical on the fuel reduction thinning treatment. So as far as the biomass operation, in wood biomass operation for national forest, I would go with biomass at the landing approach. But I take some other things, but I'm thinking the unit is really scattered. One unit here, next to the unit is 10 miles away. Another one is 15 miles away, or even 5 miles away. I'm start thinking that, well, I cannot use the pretty hard, the dump truck, travel that 10 miles like that. You cannot do that. It becomes not worth it. So I would, if I'm the planner, I would make this unit big. It's not 20 acres. Thinning, it's not 20 acres. Maybe 1,000 acres thinning. So that there's enough material. So keep that biomass operation running for a long time. That's what I would do. I mean, that's what I would suggest the people to consider. So that you can run that machine there for a little while without moving around too frequently. Good question. Thank you.
If there's any more questions, this conversation will be continued in room 34A up until 6 o'clock, and then all of you are invited to Beaver Street Brewery, and we'll be having dinner and continue trying to figure out how we're going to remove all these small diameter trees in an efficient way. Thank you.
Thank you.